In this next section, we're going to be looking at set builder notation. I'm on page 215, chapter 7, section B. Now, we've looked before at the basics of notating sets, and today what we're going to look at is a little bit more detail in that. We said before that when you're notating a set, you're going to use a capital letter as well as some brackets, but let's look at what goes in between here, and then I'm going to show you how to translate this into everyday language. So I'm running out of space here. Okay, so let's look at this. How would I read this? Well, there are a couple of different parts to this. Let's look at the first part. And this part would read X is a member of integers. Remember that Z, funny looking Z, stands for integers, and integers just means whole numbers. And a sideways pitchfork here symbolizes that X is a member of. Okay, now let's look at the second piece. We're kind of working our way backwards here. This would read that X is between -2 and 4, including, because our signs, our inequality signs, specify that both -2 and 4 are also included. So X is between -2 and 4, including -2 and 4. Now let's look at the last piece. How would we read this? Well, this will read X, or excuse me, the set of all X such that, and then you fill in the blank from there. So X such that. Now let's put all the pieces together and let's see if we were reading this entire thing, how would we do that? So we would read set A is or equals X such that X is an integer or whole number between -2 and 4, including -2 and 4. So there's our translation of this set builder notation. Now, what would this look like on a number line? Well, let's take a look. So here's the middle of our number line. And the first thing we need to notice here is that we are not including all numbers on this number line. In fact, according to our set builder notation, we're only including integers. Well, what are integers? They're just whole numbers. So if we can mark on here what we said about integers, integers equals, remember 0, positive, -1, positive, -2, and this is an infinite set. So let's mark these 0, positive, -1, positive, -2, and so on. Okay, those are only the integers, so we've got that part. And then our upper and our lower boundaries. Well, what are they? We said that the upper boundary is 4, so we know we're going to stop at 4. Here's 1, 2, 3, 4, so this is going to be it. And then we're also going to stop for a lower boundary at -2. So we're going to get rid of these pieces here. Okay, I'll just try to color over those and you can see where I'm going with this. So here's -2, that's going to be our last one. Now, we will not put a line in here, because if we put a line connecting all of these, and what we're saying is that all of these numbers that are in between, for example, 0 and 1, or 1 and 2, which would include things like 0.1, 0.2. We're saying that these are included in the set with, but they're not, because this set only includes whole numbers, and 0.1 or 0.2 are not whole numbers. So our final number line would only include just the integers. So it might look something like this, and down to -2, and that's it. We're done. This would be our finished product for that one. Let's look at another set builder notation. In this case, let's look at, this is set B, and set B is the set of all real numbers. So our first little piece here is that X is a member of real numbers, and then we're going to put the rest of our pieces together, and X is going to be less than 4 but greater than or equal to -2. So again, let's go through and let's use our different colors and let's translate this. So here's our first one. So X is a member of all real numbers. The next piece is this. X is between probably a couple different ways that you could write this. So X is between -2 and 4, including -2. And then the other piece we learned a minute ago is this thing. So this reads X such that. Putting it all together, this would read set B is X such that. We're done with this piece. X is a member of all real numbers, and X is between -2 and 4, including -2. Okay, and this would be our translation. Now, same question again, what is this thing going to look like? We put it on a graph. We've used all 3 of these. Well, here we go. Here's our number line, so we can graph this thing. Well, let's look at it, and the first question, what is this, just integers, or no? Well, no, in this case it's all real numbers, so that would include everything on this number line. Every little piece on there. So this is going to be the integers, it's also going to be the decimals and the fractions, and every little piece is going to be included on there. Now let's look at our upper and our lower boundary. Upper boundary is 4, lower boundary is -2. So let's get these marked. I'll use a color I haven't used yet. So +4 is going to be 1, 2, 3, 4 is going to be right here. Now the only thing here with this 4 is that it is not included in the set. So this actually needs to be, instead of being a closed circle, it needs to be an open circle because it's non-inclusive. Now on our lower boundary, -2, this one is inclusive, so that will be a closed circle. And because this is all real numbers, we'll go ahead and shade this number, this line representing that everything in between there is a valid solution or is a part of this set. And that will be our final answer. Now, a couple of things to note here. Set B is an infinite set. Well, why is it infinite set? You're looking at it and you say, well, that doesn't make any sense because it stops right here and it stops right there. True, but in between there, these numbers will get smaller and smaller and smaller, and there's an infinite amount of numbers or members of this set. Because here you could have included 0.1, you could also have 0.11, and 0.111111111, and it's just going to keep on going. So there are a whole bunch, in fact, infinitely many numbers in there. So if we wanted to say the number of elements in set B, we would use this little sideways 8, which is the symbol for infinity, and that notates that this is in fact, an infinite set.